Begin and recognize myself for 5 minutes. Dr. Panu, in your testimony, you described biological AI models and the threat of their misuse as raising the ceiling of harm. Would you agree that while the capabilities and potential risks of these models are difficult to measure, proactive steps to safeguard against their misuse are necessary before another major threat emerges?
Thank you for the question, Chairman. Yes, I do agree that proactive measures are necessary. I think that biological AI models that could pose societal risk are a small subset of overall biology, AI-enabled biology research. That small subset needs to be better defined and scoped, and oversight should be conducted for those models.
Given the rapid advancements that we're seeing in AI and synthetic biology, how urgent is it to be proactive and conduct oversight and mitigate risks as a part of any overreaching strategy, actually to protect the medical safety of all Americans?
Thank you for the question. I think that the rapid pace of AI advances do warrant proactive oversight of this technology for risks that can be anticipated. I think society has had a challenging time exactly predicting how and when AI will advance. And so rather than relying on guesswork or prediction, we should have methods for evaluating capability advancement.
Thank you. Mr. McKnight, recent reports have indicated that China is collecting large amounts of biological data, both from their own population and from abroad. This data could be used to develop AI programs with some of the concerning capabilities that we have discussed here this morning. Let's hone in on that. What types of biological data do you think are the most vulnerable to being misused when paired with AI?
Thank you, Mr. Chairman. We appreciate the question. The way we think about biological data and the threat that it poses is if you think about the entire planet, the vast majority of biological data is the code that Dr. Diggins talked about. All of the living things on the planet are coded in DNA. Today, to a first-order approximation, we monitor very little of it. If you think about the corollaries with cybersecurity or with any other type of security where we're looking at any adversarial threat constantly, persistently, pervasively, the challenge is when you take that diversity of information and then you combine it with AI tools, the threat frontier of what could be made changes dramatically. And until we are able to defend by using the same AI tools that we use to create new models and flip them around to interpret data coming out of the environment, whether it's natural or man-made, we are going to be essentially blind in detecting this brand new, amazing number of threats that could be invented over the next 1 to 50 years. And I think it's very important we recognize the scale of the challenge that is facing us.
Dr. Diggins, are the DNA synthesis screening regulations that are currently in place adequate to protect against malicious actors seeking to create a bioweapon?
Thank you for the question, Mr. Chairman. We don't feel they are. Their current regulations focus on acquisition and possession of cultures, live species, viruses, things like that. There's very little direct regulation of the synthesis industry itself, and we feel that mandating these screening practices is an important route to help spread the broad adoption and global uniformity of these practices.
In follow-up, Dr. Diggins, do you see a pathway where an AI-generated sequence designed to evade sequence screening algorithms is able to bypass the current safeguards?
So the work we've done with Microsoft, I think, has shown that the current generation of models is not sufficiently good at doing that. But we certainly see the capability of these models improving, and the next 2 to 3 years, that's not an unlikely scenario.
Elaborate on that. Do you see where advances in biologic design models can lead to sequences that can totally evade any attempts at detection? Is that a possibility?
On the individual protein function level, yes. So thinking like something like a toxin, redesigning that, I think there's a good chance in the next 2 to 3 years where you might see proteins where we wouldn't be able to detect.
In my final few seconds here, in your testimony, you stated that you screen requests for genetic material and that you at Twist have denied some of those requests. How frequently has that occurred in the last 6 months, year?
It's extremely infrequent, which I think we should all find comforting. It's happened maybe a dozen times over the 10 years that I've been at Twist.
And have you seen that change since you've been at Twist? You said that that's a relatively small number over a 10-year time span. Have you seen in recent years an increased number of requests that you have had to deny?
I can't say that we've seen an appreciable increase in that rate, no.
I thank you. My time has expired. I yield now to the ranking member for her 5 minutes of questioning.